Welcome to number 9 from the system assessment that we took right before the break. This is one of those notorious I'm thinking of a number type of questions. The digits of a 2-digit number add up to 11. And if you reverse the order of the digits, the new number is 63 larger than the original number. So we have two numbers. We have number A, which is actually, we'll say it this way. So we have a number. Let's say the tens place is x, is the tens place digit, and y is the ones place digit. Okay, so we know that we have this number where x, the tens place digit, plus y equals 11. But we also know that if we take that number and reverse it and make it yx minus xy will equal 63. We have to come up with a way to express it as an actual number. Well, since the tens place is always going to be times 10, what we can do is we can, if we have the number xy, that's our original number, and we have yx, we're subtracting them, we get 63. We can't say yx and xy and have it actually make any sense. What we have to do is we have to convert these into actual expressions for the number. So in this case, 10x is what the tens place is. So 10 times. So if that were 73, that would be x would be 7. So it would be 10 times 7 is 70, and y would just be the 3, and that's the ones place. So we leave it alone. Now, if we reverse the digits, we reverse the power of the particular digit. So that's going to be 10y, because that's in the tens place, and just x for the ones place. So now we have two expressions. We have an expression here, 10x plus y, which represents our original number. Then we have an expression, 10y plus x, which represents the reversed order of the two digits in our original number. So now we just have to organize this, so we end up with two equations. We've already got our first one, x plus y equals 11. Now we can do this. We end up, so I'm going to keep it in order with x's first and y's second. So I'm going to first deal with the x. So x minus 10x is negative 9x. And then 10y minus y is going to be 9y. I'm going to keep these capitalized since I already started off capitalized. Okay, and that's going to equal 63. All right, my next step is to bring the two equations together. I have two ways I can do this. I can use substitution or I can use elimination. I'm going to go with my bias, which is elimination, but I will show you how to do a substitution as well. But for right now, I'm just going to bring this down here. I've got my two equations together. Now I look here and I see all these 9s in here, and 63 is a multiple of 9. I think I could probably factor 9 out. So if I factor 9 out of this, I get just negative x. I factor 9 out of that, I get y. I factor 9 out of 63, I get 7. Well, I've done that. Now I notice I've got opposite coefficients here of negative 1 and 1, and I've got the same coefficients here. So I can solve this first by adding them. So I'll add them, and I end up with 2y equals 18. That I divide both sides by 2, so y has to equal 9. Okay, so I now have my ones place digit. My ones place digit is 9. All right, I'm going to go back here, and instead of adding them, I'm going to subtract them. So when I subtract them, negative x minus x is negative 2x. Y minus y is nothing. And 7 minus 11 is negative 4. I divide both sides by negative 2. And so x equals because -4 divided by -2 is 2. So my ones place digit I figured out was 9. My tens place digit I figured out is 2. So my number is 29. Now, I'm going to go ahead and prove that that actually is the number. I'm going to reverse the digits, 92, and I'm going to subtract 29 from that, and that will in fact give me 63. And if I added the digits 2 plus 9, I do get 11.